In this example, suppose there are 100 students in a population of which 45 are female and 55 are male. If 3 students are randomly selected, find the probability that they are all female. Okay, so basically what we're trying to do is find the probability of getting a female for the first student is female. So I'll use a subscript 1 to note that they are the first person's going to be a female. And the second person is going to be a female. And the third person is going to be a female. Okay? So you're going to select these students from the population of 100 students, right? And if you're using, you don't want to select the same person twice, right? Because you are selecting 3 different students. So these, if Mary's selected as the first female, she can also be selected as the second female, right? So these are 3 different females. So probabilities are going to be dependent, right? These events are going to be dependent, right? All right. So let's go ahead and use our multiplication rule where we have a dependence type structure. Okay. So we're going to have the probability of getting the first female, right? And then we're going to do the probability of the second times the probability of getting the second one as a female, given that the first one selected was a female. Okay? So, one female being out of the group changes the probability for the next one being a female. Okay? And then the third one is also going to be a female, given that the first 2 were also female. So female for 1 and female for 2. Okay, so this is an extension to the multiplication rule for dependent events. Remember, for the multiplication rule, if you have A and B and C, this will be the probability of getting A times the probability of getting B, given that A already occurred, times the probability of getting C, given that A and B already occurred. Okay, so we're doing the same thing. A is the first female, B is the second female, and C is the third female. All right, so now let's calculate this probability. So the probability of getting first female will be, there are 45 females in this population out of 100. Okay, so now for the second female, 1 female is already selected. Okay, so there's only 99 students in our population because we've already selected one of them. Like say it was Mary, right? So Mary's already selected. She's out of the population. So now I only have 99 students left. So what's the probability of getting another female? Well, remember, Mary's out of the population. So we don't have 45 females anymore. We only have 44 standing there. Okay? Now as we go on to the third female, say this was Sarah or some other girl, right? So Sarah's out of the population. So we only have 43 females left out of just the 98 that are standing there. All right, so if we do this multiplication, we should get 0.088.